Hello, welcome to Simplify with Mr. Pi. Today we're doing Lesson 4 of Module 3. Today's question is, how do I rewrite an expression to help shed light on the problem? In this first exercise, we are going to ask you to distribute out to get an equivalent expression, and then also to factor out to get an equivalent expression. So let me give you an example here. First, let's say we have 4x plus 4. And that 4 is that first number. So I'm going to factor out, I'm going to multiply the 4 times x and the 4 times 4 to give me 4x plus 16. Now on the next 4, let me scroll down some so you can see them. On the next 4, I want you to find the greatest common factor, and then that will become your first number. So let's say we have 6x plus 18. So the question you ask is, what is the greatest common factor of 6 and 18? That would be 6, so that becomes my first number, and then my parentheses then becomes the next two numbers. 6 times x equals 6x, and 6 times 3 equals 18. So I want you to give yourself about 2 minutes. Try all 8 of these problems. I'm not going to grade you on it or anything. Just I want you to try it, and then I'll go through them real quick. And you can check yourself and see how you did. All right, let's go through these real quick, and you can see how you did. 2 times x equals 2x. 2 times 5 equals 10. 3 times x equals 3x. 3 times 4 equals 12. 6 times x equals 6x. 6 times 1 equals 6. 7 times x equals 7x. And I'm going to keep my subtraction sign. And then 7 times 3 equals 21, which I can also write as plus negative 21. The greatest common factor of 5 and 30 would be 5. 5 parentheses x plus 6, because 5 times 6 is 30. Greatest common factor of 8 and 8 is 8. Greatest common factor of 3 and 12 is 3. Keep my minus sign, and then 4. And then my greatest common factor of 15 and 20 is 3. 5. Oh, nope. My apologies. Not 3. I did it backwards. 5. 3x plus 4, because 3x times 5 equals 15, and 4 times 5 equals 20. Now, what are we doing when we are factoring out? Let's do this one, 15x plus 20. What we're actually doing is we're dividing both of them by 5. Divide by 5, divide by 5. I can divide them both by 5. And I know that 5 times 3x is the same thing as saying 15x times 1/5, or divide by 5. We're just like we've done before. So if I can find the same number to take out, that will become my number in front of the parentheses. Let's do 8x plus 4. What number can I factor out? I can factor out 2, 4x plus 2. Yes, this is a correct number that I can factor out. But when you do factor out, you want to get the greatest common factor. And the greatest common factor is 4, 2x plus 1. Now, this first one is correct, but when you want to factor out, you want to get the greatest common factor. So this first one is a correct factoring, but to have the best possible factoring out, you want to find the greatest common number between the two, which would be 4. Exercise 1, I want you to try A through E. Attempt all 5 of these. Raise your hand, I will check on them, and then we can move on. Example number 2, let the variables x and y stand for positive integers, and let 2x, 12y, and 8 represent the area of the 3 regions in the array. Determine the length and the width for each rectangle if the width is the same for each rectangle. So I have to find the area. I know that this box is 8 units. I know that this box right here is 12y units, and this box right here is 2x units. So to find this number here, we need to find the greatest common number of 2, 12, and 8. That would be a 2. So if I know that this is 2 units high, I know that this unit would be x, and this unit would be x, and that would be 2x, which would fill up that my area, which is not 2x, sorry, just x. I am x wide and 2 high. And so this I would know I would have to fill in 1, 2, 3, 4, 5, 6 y's wide. 6y, and that would be 4. So my two equivalent expressions would be 2x plus 6y plus 4, or 2x plus 12y plus 8. All right, I want you to try exercise 2. See if you can get it before I show you. So it's telling you to write the product and the sum of the expressions being represented in the rectangular array. That would be one expression, and that would be the other expression. So the 2 would be 2 parentheses 12d plus 4e plus 3, or the other expression would be 24d plus 8e plus 6. Next one, factor out 48j plus 60k plus 24 by finding the greatest common factor of these terms. So first, let's find the greatest common factor. What did you find? The greatest common factor would be 12. And then 12 times what equals 48j? Oh, that would be 4j. 12 times 5k equals 60k. And then 12 times 2 equals 24. I can factor it out, and I get right back to this answer right there. Exercise 3. For each expression, write each sum as a product of two factors. Emphasize the importance of distributive property. So let's, on this one, A, 2 times 3 and 5 times 3, but we need to write it as the product of two factors. So I can factor out that 3. Take that 3 out. Ooh, let me use black. Take that 3 out, and what am I left with? 2 plus 5. Now I have 1, 2, 3 of the same thing, so I can write the 2 plus 5 once and say I have 3 groups of those. C is a little bit tricky, but I know you can understand it. Let's go through this step by step. First, let's rewrite it using commutative properties. 2 times 2 plus 5 times 2 plus 2 plus 5. So all I did is I took this and I moved it there, and then I took that 5 plus 2 and I moved it there, and then I rearranged to put my 2 up in the front and my 5 second, and you'll see in a second why. Next, this 5 times 2, it's in parentheses, so we need to do that first. But we also have a times 2 here as well. So if I take out this 2, it can also be represented by this same 2. So if I rewrite it 2 plus 5, this 2 right here kind of becomes this 2 as well. And then this 2 just gets brought right back down, and this 5 gets right back down. Let me rewrite the rest of the expression, 2 plus 5. And then now I have 2 groups of 2 plus 5 plus another group of 2 plus 5, which equals 3. 2 plus 5. Answer D. I can factor out the 2 3's. So 3, and I'm left with x plus 5. E, I have 1, 2, 3 groups of x plus 5. For F, first, let's do my multiplication. So let's rewrite that as 2x plus 5 plus x plus 10. And now that we have them all additions, now that they're all plus signs, we can use the commutative property, we can use the associative property, and let's rewrite it. 2x plus x plus 5 plus 10, and I can now easily combine my like terms of my whole numbers and my numbers, and I'm left with 3x plus 15, and I can factor out my 3, leaving me x plus 5. Let's move down to the next one. G, I can factor out the 3 on both of them, 3, and I'm left with x plus y. I have 1, 2, 3 groups of x plus y, so 3 x plus y. This next one, they are all plus signs. So I'm going to combine my like terms. I'm going to combine my 2x with my x, and I'm going to combine my y with my 2y, and I'm left with 3x plus 3y. I can factor out that 3 from both of them, and I get 3x plus y. Example number 3. A new miniature golf and arcade opened up in town. For a convenient ordering, a play package is available to purchase. It includes 2 rounds of golf, 20 arcade tokens, and $3 off the regular price. There's a group of 6 friends purchasing this package. Let G represent the cost of a round of golf, and T represent the tokens. Write 2 different expressions that represent the total amount this group spent. Explain how each expression describes the situation in a different way. First, what are we trying to figure out? We're trying to get 2 different expressions that represent the total amount the group spent. So what did we spend our money on? 2 rounds of golf, 20 arcade tokens, $3 off. And then the other important fact is that there is a group of 6. So 6 friends each got 2 rounds of golf, and remember it said G means my golf. Got 20 tokens and saved $3. So with that word each there, that will become my number that is my distributing number. So I can rewrite this 6 2G plus 20T, and I'm going to say minus 3 because I'm getting $3 off. Another equivalent expression, I'm going to factor out that 6. 6 times 2 equals 12G. 20 times 6 equals 120T, and minus 18. Now explain how each describes in a different way in the situation. So this one right here tells us the total cost for all 6 people. And say one person is paying for all 6, it's much easier just to know the total cost. But this one tells you the cost of each person, and then you multiply it by 6. So in this situation here on this first one, say one person has to cancel, and I only have 5 friends, I can easily just change this number, cancel it out, change it to a 5, and I do the same equations and I can figure it out. I cannot do it on this equation. So before we move on, let's talk about the opposites. On the first chart on lesson 2, you figured out the opposites. The opposite of 2 is negative 2. The opposite of x is negative x. Another way of we would use the additive inverse. What number brings it back to 0? And another way of looking at that is multiplying it by negative 1. So negative 1 times 2 equals negative 2. We're just multiplying it by negative 1. Negative 1 times x equals negative x. So you multiply it by negative 1 to get that opposite of it. Sometimes you're just going to see a negative sign and then that number, or a negative sign and then that x. And I like to assume that there is a 1 there. Just like if you have an x by itself, like this x, you would say that that is 1x. We don't need to put the 1 there because we assume that the 1 is there, and we're doing it just the same as that. And then we distribute that 1 to the negative 2, distribute that 1 to the x, and we get negative 2, or we get negative x. So what's the opposite of negative 6v plus 1? I'm going to get negative 1, and I'm going to multiply it out. Or I can write negative sign. I can do that either way. These two are equivalent because I assume that that is a negative 1, and then it becomes exactly the same as the one before. I'm going to distribute it out, and I would rewrite that negative 1 times negative 6v plus negative 1 times 1. So I'm taking this negative 1 and I'm distributing it out both times. And so that's negative 1 times the first one. That's negative 1 times the second number in that equation. And then that would become 6v plus negative 1, which we can also write as 6v minus 1. So let's rewrite 5a minus 3b in standard form. Let's justify each step as we're going along. So the first step is the rule of subtraction. So let's change these two subtraction signs to a plus. And remember, when you change the subtraction to a plus, the next number becomes the opposite, which we were just talking about before. So 5a plus, then my next number becomes the opposite, a. Oh, and then I got to do that again, opposite of 3b. So I took the opposite of 3b, which is negative 3b, the opposite of, and then the a stayed the same, but then I took the opposite of all this with that negative sign right there. Now we're going to distribute out. So we're going to assume that there is a 1 right there, and we're going to distribute. We're going to distribute out that number. 5a plus negative 1 times a plus negative 1 times negative 3b. Now, going to then do my math. 5a plus negative a plus negative times a negative equals a positive 3b. Now I'm going to combine my like terms. 5a minus 1a equals 4a plus 3b. That would be the simplest answer. Now I want you to try these two, just like we did before. First, use the rule of subtraction, get rid of all those plus signs, then distribute that across, then combine your like terms and see if you can get the answer. When you are done, raise your hand and I will come to you and check. Okay, before we end, I want to talk about the two things that we did today. The first thing that we did today is finding that opposite of the number. We know it is the additive inverse. To find the opposite of the number, you're going to put that negative 1 and then you're going to multiply it by whatever it's in there. Let's say it's x plus 3. I'm just distributing it out. And now that becomes negative x plus negative 3. The other thing that we were doing is we were factoring out a number, 6x plus 18. I know that my greatest common factor of these would be 6. I can divide both of these by 6 or multiply by 1/6, and that is the same as saying 6 times x plus 3. So we're finding a number to distribute out because, again, remember 6x is the same thing as saying x times 1/6. So we can divide by 6 or we can multiply by 6. Now on the problem set, I want you to try 5 of these, complete 5 of these, complete number 3 or 4, and then complete 5, 6, and 7. Now again, remember standard form. That means there is only one whole number and one number with each variable. If I say 2x plus x, that is not in the standard form. I cannot have two of the same variables and be standard form, so I need to write that as 3x. Thank you for listening to today's lesson, and I hope you enjoyed it.